Question number 4. What is the value of x in the sequence 20, 10, 10, 15, 30, 75, x? Here in this sequence, the sequence is progressing by the second term divided by first term. 10 by 20 equal to 1 by 2. Then third term 10 divided by second term 10 equal to 10 by 10 equal to 1. This we can write as 2 by 2. Then fourth term 15 divided by third term 10. 15 divided by 10. This is equal to 3 by 2. Then fifth term 30 divided by 15 equal to 4 by 2. In this way 75 divided by 30 equal to 5 by 2. X divided by 75 equal to 6 by 2. This is equal to 3. Then we can say from here x equal to 3 into 75, which is equal to 225. So the sequence is progressing by 1 by 2, 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2. So finally we get x equal to 225. Option D is the right answer. Question number 5. An identity card has the number A, B, C, D, E, F, G. Not necessarily in that order, where each letter represents a distinct digit 1, 2, 4, 5, 7, 8, 9 only. The number is divisible by 9. After deleting the first digit from the right, the resulting number is divisible by 6. After deleting 2 digits from the right of original number, the resulting number is divisible by 5. After deleting 3 digits from the right of original number, the resulting number is divisible by 4. After deleting 4 digits from the right of original number, the resulting number is divisible by 3. After deleting 5 digits from the right of original number, the resulting number is divisible by 2. Which of the following is a possible value for the sum of the middle 3 digits of the number? There is an identity card. It has a 7-digit identification number. Those 7 digits are made up of these 7 digits 1, 2, 4, 5, 7, 8, 9. Not necessarily in that order. Then there are given some statements here. We have to find possible value for the sum of the middle 3 digits of the number. Suppose 1, 2, 3, 4, 5, 6, 7. These are the 7 digits. 7-digit number. Then we have to find sum of third, fourth and fifth digits of that number. Now let us see the statements given here. The number is divisible by 9. What is the divisibility test for 9? Sum of the digits is divisible by 9. Then the number is divisible by 9. The identification number is made up of these 7 digits. Then sum of these 7 digits equal to 1 plus 2 plus 4 plus 5 plus 7 plus 8 plus 9. This is equal to 36. 36 is divisible by 9. Therefore, the number is divisible by 9. It is given here. Now see the second statement. After deleting the first digit from the right, the resulting number is divisible by 6. Suppose these are the 7 digits. After deleting last digit from the right, first digit from the right, the resulting number is divisible by 6. What is the divisibility test for 6? If the number is divisible by both 2 and 3, then the number is divisible by 6. That means to be divisible by 2, the last digit should be an even number. So suppose this is the first one, second, third, fourth, fifth, sixth, seventh. Then this sixth digit is an even number. Even numbers in the lot are 2, 4 and 8. So here it should be either 2 or 4 or 8. Now to be divisible by 3. What is the divisibility test for 3? Sum of the digits should be divisible by 3. Then eliminating which digit give the remaining sum of the remaining digits a multiple of 3. Eliminating 9, we get sum of the remaining digits equal to 27. 27 is divisible by 3. Therefore, the last digit is 9. And the second last digit is either 2 or 4 or 8. Now see the third statement. After deleting 2 digits from the right of original number, the resulting number is divisible by 5. Divisibility test for 5. The last digit should be either 0 or 5. In our lot, there is only 5. Therefore, the fifth digit is 5. Then, see the fourth statement. After deleting 3 digits from the right of original number, the resulting number is divisible by 4. To be divisible by 4, the last digit should be an even number and last 2 digits should be divisible by 4. So last 2 digits should be divisible by 4 means the last digit should be an even number. So fourth digit also an even number. It is either 2 or 4 or 8. Now see the fifth statement. After deleting 4 digits from the right of original number, the resulting number is divisible by 3. 4 digits. Then the resulting number should be divisible by 3. So sum of the first, second and third digit should be divisible by 3. Now see the fifth statement. After deleting 5 digits from the right of original number, the resulting number is divisible by 2. To be divisible by 2, the last digit should be an even number. Even numbers in the even last digit should be an even number. So even digits in the lot are 2, 4, 8. So even numbers are placed either in second place or in fourth place or in sixth place. Then 1, 4 and 6 are placed filled by odd numbers. We got that. Now come to the statement number 5. After deleting 4 digits from the right of original number, the resulting number is divisible by 3. 5 and 9 are already fixed here. Then the remaining digits are 1, 2, 4, 7, 8. So we need to find a combination of 3 digits which is multiple of sum of which is multiple of 3 and one of which is an even number, other two are odd numbers. Odd numbers we already got 1 and 7. Suppose the even number is 2, then 1 plus 2 equal to 3, 3 plus 7, 10. 10 is not divisible by 3, therefore 2 is ruled out. 4 plus 1 equal to 5, 5 plus 7 equal to 12, 12 is divisible by 3. Therefore, 4 is a possibility for the second place. Now see the 8 also. 8 plus 1, 9. 9 plus 7, 16. 16 is not divisible by 3. Therefore, 8 also ruled out for second position. So, second position is occupied by 4. Then first position 7. Third position 1. If third position is 1, then after deleting these 3 digits, it should be divisible by 4. So this should be divisible by 4. The last 3 and 4 should be divisible by 4. So 12 is divisible by 4. 18 is not divisible by 4. 4 is already used here. Therefore here it is 2. Then remaining number is 8 is here. Then sum of these 3 digits equal to 1 plus 2 plus 5 equal to 8. Option A is the right answer. Suppose we are placing 4 here, 7 here, 1 here, then 5 here, 9 here. 72, here it should be either, here it can be either 2 or 8. Here also, because 72 is divisible by 4, 7, but 78 is not divisible by 4. Then here it should be 8. Now see the sum of the middle 3 digits. 7 plus 2 plus 5 equal to 9 plus 5, 14. 14 is not given in the option. So from the given option, answer is option A, 8. 7 plus 2 plus 5 equal to 14. 3 plus 1 plus 2 plus 5 equal to 8. This is the answer. Question number 6. Two friends X and Y start running and they run together for 50 meters in the same direction and reach a point. X turns right and runs 60 meters while Y turns left and runs 40 meters. Then X turns left and runs 50 meters and stops, while Y turns right and runs 50 meters and then stops. How far are the two friends from each other now? They start from the same point, take it as S, then they run in the same direction for 50 meters and reach a point, take point as P. Then from P, X turns right and runs 60 meters. X turns right, this is X, and he runs 60 meters. While Y turns left and runs 40 meters. This is Y. Then from here, X turns left and runs 50 meters. From here, X turns left and runs 50 meters. From this point, Y turns right and runs 50 meters. Then how far are the two friends from each other now? So the distance between these two is 40 plus 60 equal to 100. Option A is the right answer. Question number 7. Which date of June 2099 among the following is Sunday? Here we have 4 options. 4th June, 5th June, 6th June and 7th June. We want to find which among these dates is a Sunday. We know 1st January 2001 was Monday. How we got this? 1st January, first day of AD 01 was Monday. Then after every 400 years, the next day start with Monday, because number of odd days in these 400 years equal to 0. In that way, we get 1st January 2001 is Monday. Then 1st January 2001. Keeping this as a benchmark, we can find 1st June 2099. So 1st January 2001 to 1st June 2099. There are 98 years. Then in 2099 we have to consider January, February, March, April, May, June. So here we want to find June 1st. Once you find June 1st, then you can find which among the following is a Sunday. Then how many leap years are there in these 98 years? In 100 years, we know there are 24 leap year and 76 non-leap year. And we also know 100th year is not a leap year, and 99th year also not a leap year. Then in 98 years there are 24 leap year and 74 non-leap years. Then in January there are 31 days. February 2099 it is a non-leap year, so 28 days are there. March 31 days. In April there are 30 days. In May there are 31 days. In June we have to find the 1st June 2099. So only one day. Then how many odd days are there? This is odd days. Odd days are there in 24 leap year. In one leap year, which is equal to 366 days, 366 divided by 7, we get remainder equal to 2. This is called odd days. Then in 24 leap year there are 24 into 2 odd days. In one non-leap year there are 365 days. 365 divided by 7, we get 1 odd day, so 74 into 1. Then 31 divided by 7, we get 3 odd days. Here 0, here 3, 2, 3, 1. So total number of odd days in these 98 years equal to 122. 48 plus 74, we get 122. So this we can directly find here, from here. In 100 years there are 124 odd days. If you know this fact, then 100th year is not a leap year and 99th year also not a leap year. So you can deduct 2 odd days for 99th year and 100th year. So in 98 years you get 124 minus 2, 122 odd days. Now here 122 plus 3 plus 3 plus 3 plus 2 plus 1, we get 12. So total number of odd days equal to 134. Again we can divide this by 7. So we get number of odd days equal to 1. Number of odd days equal to 1 means 1st June 2099. 1st June 2099. which is equal to the starting day. We started from 1st January 2001, which was Monday, and this also Monday. Then if 1st January 2099 is Monday, that means 7th June 2099 is Sunday. After 7 days it is Sunday. Option D is the right answer. Here we took 1st January 2001 Monday as benchmark. This exam is conducted on when 5th June 2022, which was a Sunday. You can take this also as a benchmark, but when taking this as benchmark, then it is slightly difficult to find the number of odd days. So using this method you can easily find number of odd days and Sunday of June 2099. Question number 8. A bill for rupees 840 is paid in the denominations of rupees 50, rupees 20 and rupees 10 notes. 50 notes in all are used. Consider the following statements. Statement 1. 25 notes of rupees 50 are used and the remaining are in the denominations of rupees 20 and rupees 10. Statement 2. 35 notes of rupees 20 are used and the remaining are in the denominations of rupees 50 and rupees 10. Statement 3. 20 notes of rupees 10 are used and the remaining are in the denominations of rupees 50 and rupees 20. Which of the above statements are not correct? Here, a bill of 1840 has to be paid. For that, denominations of rupees 50, 20 and 10 are there. Total 50 notes are to be used. Then, which of the following given statements are not correct? That is what we have to find. Now, let us check the first statement. 25 notes of rupees 50 are used. 25 notes of rupees 50 equal to 1250 rupees. So, using rupees 25 rupees 50 note, 1250 rupees paid. Then remaining has to be paid using rupees 20 and rupees 10, and you can use only 25 notes. Suppose all the 25 notes are rupees 20 note, that is the maximum value. Then 25 into 20 equal to 500. Then adding these two, we get 1750, which is less than 1840. Therefore, first statement is incorrect. Now see the second statement. 35 notes of rupees 20 are used. 35 into 20, we get 700 rupees. Then remaining are in the denominations of rupees 50 and 10. Here we can use 15 notes of rupees 50 and either both rupees 50 and rupees 10. Suppose all these 15 notes are rupees 50. Then we get 750 rupees. Adding these two, we get 1450, which is less than 1840. Therefore, second statement also wrong. Now see the third statement. 20 notes of rupees 10. 20 into 10 we get 200. Now 30 notes are remaining. Suppose all these 30 notes are rupees 50 notes. Then this is equal to 1500. Adding these two, this is the maximum possible value, which is equal to 1700, which is less than 1840. Therefore, this is also incorrect. So all the above statements are not correct. Option D is the right answer. Question number 9. Which number amongst 2 power 40, 3 power 21, 4 power 18 and 8 power 12 is the smallest? So here we want to find smallest among these 4 numbers. So before solving this question, we need to know a power m all power n equal to a power m into n. Then 8 power 12 equal to 8 equal to 2 cube. 8 we can write as 2 cube. 2 cube all power 12. This is equal to 2 power 3 into 12, we get 2 power 36. Then 4 power 18 equal to 2 square all power 12, all power 18. This is equal to 2 power 2 into 18 equal to 2 power 36. Option C and D are equal. And option A equal to 2 power 40, which is greater than 2 power 36. Option C and D are equal, so they can't be our answer. And option A is greater than C and D, so that is also not the smallest. Then smallest amongst these 4 is 3 power 21. Option B is the right answer. Question number 10. The digits 1 to 9 are arranged in 3 rows in such a way that each row contains 3 digits. And the number formed in the second row is twice the number formed in the first row. And the number formed in the third row is thrice the number formed in the first row. Repetition of digits is not allowed. If only 3 of the 4 digits 2, 3, 7 and 9 are allowed to use in the first row, how many such combinations are possible to be arranged in 3 rows? Here we need to arrange 9 digits in 3 rows such a way that each row contains 3 digits. Then it will be like this: 1, 2, 3, this is first row. Then 3, 4, 5, this is the second row. 7, 8, 9, you get third row. So each row contains 3 digits and these 3 digits forming a 3-digit number. Now see the next statement. The number formed in the second row is twice the number formed in the first row. Number formed in the second row is twice the number formed in the first row. And the number formed in the third row is thrice the number formed in the first row. R3 equal to 3R1. Then repetition of digits is not allowed. We have to use all the 9 digits in these 3 rows. If only 3 of the 4 digits 2, 3, 7 and 9 are allowed to use in the first row, then how many such combinations are possible? So in first row you can use 3 digits only from these 4 digits 2, 3, 7 and 9. Then how many such combinations are possible? So here you need to select 3 digits for the first row. So there is one condition. Those 3 digits in the first row, after multiplying by 3, we should get a 3-digit number, which is R3. Suppose I am choosing 273 in the first row. Then 273 into 3, we are getting 819, which is a 3-digit number. So we can use this in third row. So this can be one first row digit for one first row number. Now see another number 732. Multiplying this by 3, we are getting 6, 9, 21. So this is a 4-digit number. This can't be used in third row. So this 732 we cannot use in the first row. So what are the numbers that we can use in the first row? 273, 237, 239, 293, 279, 297, 327, 329. Only these 8 numbers we can use as number in the first row. Now multiply each numbers with 2 and 3. So here R1 into 2 we get R2, R1 into 3 we get R3. Then 273 into 2 we get 546, and 273 into 3 we get 819. So here all the digits are different, no repetition of digits. So this is the one combination we are looking for. Now see the second number, 237. 237 into 2 we get 474. Here 4 and 7 all are repeating, so we are eliminating this number. 239, multiplying by 3 we get 717. 7 is repeating, so we can directly eliminate. 293, multiplying by 3 we are getting 879. So here 9 is repeating, so we can directly eliminate. 279, multiplying by 3 we get 3 9s are 27, so 7 is coming again, so it is repeating here, so we can eliminate this. Then 297, multiplying by 3 we get 891, so 9 is repeating, so we can eliminate this. 327, multiplying by 2 we get 654, multiplying by 3 we get 981. Here all the digits are different, no repetition of digits, so this is another combination. Then 329, here multiplying by 3 we get 987. 9 is repeating here, so we can eliminate this also. So there is only 2 combination which satisfying the given condition. Our answer is option C, 2. Question number 15. X and Y run a 3-kilometer race along a circular course of length 300 meter. Their speeds are in the ratio 3:2. If they start together in the same direction, how many times would the first one pass the other? The start off is not counted as passing. X and Y run a 3-kilometer race along a circular course of length 300 meter. Suppose this is the circular track. It is 300 meter long. The entire race is for 3 kilometer. 3 kilometer equal to 3 into 1000. It is 3000 meter. Their speeds are in the ratio 3:2. Speed of X and Y are in the ratio 3:2. That means when X runs 300 meter, Y runs 200 meter. If they start together in the same direction, how many times would the first one pass the other? Suppose this is the starting point. both of them start from here together in the same direction. How many times the first one passed the other? The start of the beginning not counted as passing. When x runs 300 meter, y runs only 200 meter. That means when x complete one rotation, y complete only 200 meter. That means y lagging behind x by 100 meter. Then when x completes 600 meter, y completes 400 meter. When x completes 900 meter, y completes 600 meter. That means when x completes 3 rotation, y completes 2 rotations. That means both of them meet at the starting point. So we can say after running 900 meter, x passes the y. So in the entire course of race 3000 meter, y pass x 3000 divided by 900 times this is equal to 3. 3 times x passes the y. Option B, 3 is the right answer. Question number 16. If the order of the letters in the English alphabet is reversed and each letter represents the letter whose position it occupies, then which one of the following represents Lucknow? Here, the order of the letters in the English alphabet is reversed. So, you can see here, we reversed the order of the letters. Then, each letter represents the letters whose position it occupies. That means, A is replaced by Z, B is replaced by Y, like that Z is replaced by A. Then which one of the following represents Lucknow? So L replaced by O. So all the options are starting with O. Then U is replaced by F. So we can eliminate option A and B. Then here you can see the next 4 words are similar in both C and D. Then W is replaced by D. Therefore, option D is the right answer. Question number 17. In a tournament of chess having 150 entrants, a player is eliminated whenever he loses a match. It is given that no match results in a tie or draw. How many matches are played in the entire tournament? There are 150 entrants in a chess tournament. A player is eliminated whenever he loses a match. There is no match results in a tie or draw. Then how many matches are played in the entire tournament? Suppose entire 150 entrants are ranked from 1 to 150. Then last seed will be 150, then 149, then 148, then 147, like this. 4th seed, 3rd seed, 2nd seed, 1st seed. So the last 2 players will play first. And the winner, he prevails, and loser get eliminated from the match, tournament. And the winner of first match will play with the 148th rank member. Then winner of this match will play with the 147th rank member. In each match, one man get eliminated. Then in 148th match, 148 people will get eliminated. So the 148th match will be between the 2nd seed versus winner of the 147th match. So this winner will play with the first seed in 149th match. So in 149th match, 149 people will get eliminated. The last one will be the champion in the tournament. So total matches played in the entire tournament equal to 149. Option C is the right answer. Question number 18. How many 3-digit natural numbers without repetition of digits are there such that each digit is odd and the number is divisible by 5? Here we want to find how many 3-digit natural numbers are there without repetition of digits. Each digit is odd and the number is divisible by 5. Suppose this is the 3-digit number. Each digit is odd and the number is divisible by 5. We know there are 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In this, 1, 3, 5, 7 and 9 are odd digits. So we have to make 3-digit numbers using these 5 digits. And it should be divisible by 5 also. What is the divisibility test for 5? If a number is divisible by 5, then its last digit should be either 0 or 5. Then here we have to use the odd digit, so last digit should be 5. Then we have to fill the remaining 2 spots using 1, 3, 7, 9. Suppose I am taking 1 and 3. Then numbers possible are 1, 3, 5 and 3, 1, 5. So in this way we can take 2 digits out of these 4 digits and we can arrange them. So we get total number of numbers. So how can we find that? Taking 2 digits out of 4 digits and arranging those 2 digits in 4p2 ways. 4p2 means 4 factorial divided by 4 minus 2 factorial. This is equal to 4 into 3 into 2 factorial divided by 2 factorial. 2 factorial, 2 factorial cancelled. We get 4 into 3 equal to 12. So there are 12 3-digit numbers whose digits are odd and the number is divisible by 5. Option B is the right answer. Question number 19. Consider the question and 2 statements given below. Question: is x an integer? Statement 1. X by 3 is not an integer. Statement 2. 3x is an integer. Which one of the following is correct in respect of the question and the statements? So here we need to answer the question: is x an integer, based on these 2 statements. So take 2 cases. Case 1. X equal to 5. Then statement 1. X by 3 equal to 5 by 3 is not an integer. Okay. Then statement 2. 3x equal to 3 into 5 equal to 15. It is an integer. So both the statements are satisfying and x is an integer. Now see the case 2. X equal to 5 by 3. Here x is not an integer. Now let us see whether these statements are following this digit, this number. When considering statement 1, x by 3 is not an integer. X by 3 equal to 5 by 3 by 3 equal to 5 by 9. It is not an integer. This is true. Now see the statement 2. 3x equal to 3 into 5 by 3 equal to 5. 5 is an integer. So when x equal to 5 by 3, a non-integer, and x equal to 5, an integer, both the statements are satisfying. That means both the statement 1 and statement 2 are not sufficient to answer the question, is x an integer? It can be an integer or not. Question number 20. The increase in the price of a certain item was 25%. Then the price was decreased by 20% and then again increased by 10%. What is the resultant increase in the price? Let us take the initial price of the item equal to 100. Initial price of the item equal to 100 rupees. For easy calculation, we took initial price of the item equal to 100 rupees. Then the price of the item is increased by 25%. 25% increase. 25% of 100 equal to 25. Then the resultant equal to 100 plus 25 equal to 125 rupees. Then decreased by 20%. 20% decrease. 20% decrease from 125. So what is the 20% of 125? 10% of 125 equal to 10% of 125 equal to, place a decimal after one place, then it become 12.5. This is 10% of 125. Then 20% of 125 equal to 2 into 12.5, we get 25. That means 20% decrease equal to 125 minus 25 equal to 100. So here we got the initial price of the item. Then again increased by 10%. What is the resultant increase in the price? So resultant increase in the price means after this 100 again increased by 10%. So resultant increase equal to 10%. Option B is the right answer. Question number 24. The letters A, B, C, D and E are arranged in such a way that there are exactly 2 letters between A and E. How many such arrangements are possible? There are 5 letters A, B, C, D and E. They are arranged in such a way that there are exactly 2 letters between A and E. Then how many arrangements are possible? Suppose these are the 5 places where we need to arrange these 5 letters. Then suppose A is here. Then between A and E there is exactly 2 places. Then after 2 places it is E in the 4th place. And another arrangement possible is if A is in the 2nd place, then you can place E in the 5th place. Then again we can arrange A and E. Instead of A we can keep E. Then exactly after 2 places in 4th place we can keep A. Similarly here also instead of 2nd place we can keep E, and in the 5th place we can keep A. That means A and E we can arrange in these two places in two ways. Here also in two ways. So the remaining three digits B, C, D you can arrange in the remaining three places in 3 factorial ways. And there are two arrangement of A and E. Similarly here also the remaining 3 letters you can arrange in remaining 3 places in 3 factorial ways, and there are two arrangement of A and E. So total 3 factorial equal to, this is equal to 6, then 6 into 2 equal to 12, here also 12, total 24 arrangements are possible. Option C is the right answer. Question number 25. Consider the question and two statements given below. Question: is Z brother of X? Statement 1. X is a brother of Y and Y is a brother of Z. Statement 2. X, Y and Z are siblings. Which one of the following is correct in respect of the question and the statements? Here we need to answer the question: is Z brother of X? For that we have two statements here. Let us see the first statement. Statement 1. X is a brother of Y and Y is a brother of Z. X is a brother of Y. Here I am representing male member in a square and the same generation with a horizontal line. Then Y is a brother of Z. Y is a brother of Z. Here the gender of Z is not specified. Therefore, we cannot answer is Z brother of X. He may be brother or sister. So statement 1 alone is not sufficient to answer the question. Now see the second statement. X, Y and Z are siblings. From first statement itself we got X, Y, Z are siblings, and we could not answer the question is Z brother of X. So both first and second statements are not enough to answer, not sufficient to answer the question. Option D is the right answer. Question number 26. On one side of a 1.01 kilometer long road, 101 plants are planted at equal distance from each other. What is the total distance between 5 consecutive plants? Here, on one side of a 1.01 kilometer long road, 1.01 kilometer long road, 101 plants are planted at equal distance from each other. 101 plants are planted at equal distance from each other. Then, what is the total distance between 5 consecutive plants? So, to find this, first we need to find what is the distance between two adjacent plants. So, here you can see number of gap between two adjacent plants equal to 1. Number of gaps between two adjacent plants, 3 adjacent plants equal to 2. Number of gaps between 4 adjacent plants equal to 3. Likewise, number of gaps between 101 plants equal to 101 minus 1, 100. There will be 100 gaps. So we need to find value of one gap. 1.01 kilometer equal to 1.01 into 1000 meter. This is equal to 1010 meter. So 100 gap equal to 1010 meter. Then each gap equal to 1010 divided by, I am taking this 100 right side, then 10.1 meter. So here we need to find total distance between 5 consecutive plants, number of gaps between 5 consecutive plants equal to 4, then distance between 5 consecutive plants equal to number of gaps between 5 consecutive plants equal to 5 minus 1, that is 4, and each gap equal to 10.1 meter. Then distance equal to 4 into 10.1 equal to 40.4 meter. Distance between 5 consecutive plants equal to 40.4 meter. Option B is the right answer. Question number 27. A, B and C are 3 places such that there are 3 different roads from A to B, 4 different roads from B to C, and 3 different roads from A to C. In how many different ways can one travel from A to C using these roads? There are 3 places, A, B and C, and there are 3 different roads from A to B. 1, 2, 3. 3 different roads from A to B, and 4 different roads from B to C. 1, 2, 3, 4. And 3 different roads from A to C. 1, 2, 3. Then in how many different ways one can travel from A to C using these roads? A to B one can reach. A to B one can reach in 3 ways, and B to C one can reach in 4 ways. Then A to B to C one can reach in 3 into 4 ways, which is equal to 12. Then here we know directly A to C there are 3 ways. So total ways to reach A to C equal to 12 plus 3. 12 plus 3 equal to 15. Option C is the right answer. Question number 28. A has some coins. He gives half of the coins and 2 more to B. B gives half of the coins and 2 more to C. C gives half of the coins and 2 more to D. The number of coins D has now is the smallest 2-digit number. How many coins does A have in the beginning? A has some coins. Let us take number of coins with A initially. Number of coins with A initially equal to X. Then X gives half of the coins and 2 more to B, and B gives half of the coins and 2 more to C. C gives half of the coins and 2 more to D. Then how many coins does A have in the beginning? That is what we have to find. We have to find the value of X, number of coins with A initially in the beginning. So A gives half of its coin, half of his coin and 2 more to B. Then B has X plus 4 by 2 coins. Then B gives half of what he has plus 2 more to C. Then C has X plus 4 divided by 4 plus 2, which which is equal to x plus 12 divided by 4 coins. Then C gives half of what he has, plus 2 to D. Now D has number of coins which is equal to the smallest 2-digit number. Smallest 2-digit number equal to 10. Then what is the value of x? What was the number of coins with A initially, in the beginning? So from here, x plus 12 divided by 8 plus 2 equal to 10. X plus 12 divided by 8 equal to, I'm taking this 2 here, then 10 minus 2 equal to 8. Then x plus 12 equal to 8 into 8 equal to 64. X equal to 64 minus 12 equal to 52. Number of coins with A in the beginning equal to 52. Option D is the right answer. Question number 29. In the series A, AB, ABC, ABCD, ABCDE, etc., which letter appears at the 100th place? Here we have a series A, AB, ABC, ABCD, ABCDE, ABCDF, EF. So it is progressing like this. Which is the letter in the 100th place? The first place it is A, then AB, ABC, ABCD, ABCDE, ABCDEF. It is growing like this. We need to find which is the letter in the 100th place. So first we want to find on which group this 100th place included. So to find that, here you can see this is natural numbers. Sum of natural numbers equal to sum of n natural numbers equal to n into n plus 1 divided by 2. Suppose n equal to 10, then sum of first 10 natural numbers equal to 10 into 11 divided by 2 equal to 55. But here it is 100. So let us take n equal to 13. Then sum of first 13 natural numbers equal to 13 into 14 divided by 2. We get 91. So in the next group there will be, when n equal to 14 more members will be there. So to reach 100, 9 more letters required. So from 14th group, A to 9th letter it is, 9th letter in the English alphabet it is I. So in the 100th place it will be I. Option C is the right answer. Now from here, first you found n equal to 10 equal to 55. Then in the next group it will be 11. So this is 66. Then again 12. Then this is 78. Then plus 13. So this is 91. This way also you can find. Then in the next group there will be 14. So we need only 9. The 9th letter is I. Question number 30. 3 persons A, B and C are standing in a queue, not necessarily in the same order. There are 4 persons between A and B and 7 persons between B and C. If there are 11 persons ahead of C and 13 behind A, what could be the minimum number of persons in the queue? So here we need to find minimum number of persons possible in a queue with the given conditions here. There are details of 3 persons A, B, C are given. We want to find minimum number of persons possible in that queue. So there are 3 persons A, B, C. Between A and B, there are 4 persons. Between B and C, there are 7 persons. So this A, B, C, we can arrange in 3 ways. A, B, C, B, A, C, A, C, B. So there are 4 between A and B, 7 between B and C. This is one arrangement. Then there are 4 between A and B and 7 between B and C. That means there are 2 between A and C. 2 plus A, 4, 3. 3 plus 4, 7. Then third arrangement. There are 4 between A and B and 7 between B and C. So in a linear arrangement, A, C, B, this is not possible. Third arrangement is not possible. Now see the first arrangement. In first arrangement, how many persons are there? A, 1 person. Then between A and B, 4 persons. Then B, another person. Between B and C, 7 persons. Then C, 1 person. Total 14 persons are there. In second arrangement, here we can see B, 1 person. Plus between B and A, there are 4. Or directly between B and C, there are 7. Then plus C, there are only 8 persons. So here we need to find minimum number of persons in the queue. So first we consider the second arrangement BAC. So B, A, C. Between A and B, 4. B and C, 7. A and C, 2. Now see the next statement. If there are 11 persons ahead of C and 13 behind A, this is right side and this is left side. Right side is the front side. So 11 persons ahead C means there are 11 persons in this side, and 13 persons behind A means 4 plus 1, there are already 4, 5 plus 8, there are 13 persons. Then total number of persons in the queue equal to 8 plus B equal to 1 person. Then between B and C there are 7. Then C plus 11, we get 28. Earlier we considered right side as the front side of C. Now we are considering back side of left side as the front side of C. Then the arrangement will be B, A, C. This is 7, this is 4, this is 2, this is right side and left side, and 11 persons ahead of C. So up to this, up to B, up to B, 7 plus B, there are 8 persons. Then 3 more persons. Then 8 plus 3, there are 11 persons ahead of C. and 13 persons behind A. Behind A, there are already 3, 10 more adding here. Then total persons in the queue equal to 3 plus 8 plus, we are considering C, 1 plus 10. This is equal to 22. So the minimum number of persons in the queue equal to 22. Option A is the right answer. Question number 35. How many seconds in total are there in X weeks, X days, X hours, X minutes and X seconds? We know 1 week equal to 7 days. Then we know 1 day equal to 24 hours. This is 1 day. Then 1 hour equal to 60 minutes. Then 1 minute equal to 60 seconds. So 1 week equal to 7 into 24 into 60 into 60 seconds. Now we want to find what is that, how many seconds are there in total in X weeks, X days, X hours, X minutes. X week equal to 7 into 24 into 60 into 60 equal to 3600 seconds. X week equal to. Then X days equal to X into 1 day equal to 24 into 60 into 60 second. So X days equal to X into 24 into 3600 seconds. Then X hours equal to 1 hour equal to 60 into 60 seconds. That means 3600 seconds. Then X minutes equal to X into 60 seconds. Then X seconds we are writing as such. Then take X outside from all these. Then we get 7 into 24 into 3600 plus 24 into 3600 plus 3600 plus 60 plus 1. Now adding all these, here the units place digit is 0, should be 0 because there are 3 zeros in the number. Here also units place digit is 0. Here also units place digit is 0. Here also 0. Then units place digit of this sum total will be 1. So see the options. Only in 2 options we have 1 in the units place digit. So we can eliminate these 2 options. Now what will be the digit in the tens place? Here tens place also there will be 2 zeros in this product. That means tens place digit equal to 0. Here also tens place digit equal to 0. Here tens place digit equal to 0. Then finally in 60 tens place equal to 6. Here there is no tens place. So tens place digit will be 6. So from the given options, here tens place digit is X, 8 and here it is 6. Therefore adding all these we get 694861 X. Option D is the Right answer. Question number 36. P, Q, R, S, T and U are 6 members of a family. R is the spouse of Q, U is the mother of T and S is the daughter of U. P's daughter is T and R's son is P. There are 2 couples in the family. Which one of the following is correct? There are 6 members in a family: P, Q, R, S, T, U. R is the spouse of Q. R is the spouse of Q. I am representing spouse with a into mark. U is the mother of T. U is the mother of T. Relationship between 2 generations I am representing with a vertical line and female member in a circle. Here U is mother of T. S is the daughter of U. S is the daughter of U. P's daughter is T. So P's daughter is T. That means P is husband of U. R's son is P. Here you can say R's son is P. Therefore, R and Q are parents of P. Now we got 2 couples in the family and all other statements are drawn in the family tree. Now see the first statement. Q is the grandfather of T. We don't know the gender of Q. Therefore, we cannot say Q is the grandfather of T. Q is the grandmother of T. That also we can't say. So we eliminate B also. R is the mother of P. We don't know R is mother or father. R is parent of P. So this is also false. T is the granddaughter of Q. T is the granddaughter of Q. That is true. Option D is the right answer. Question number 37. Consider the question and 2 statements given below in respect of 3 cities P, Q and R in a state. Question. How far is city P from city Q? Statement 1. City Q is 18 km from city R. Statement 2. City P is 43 km from city R. Which one of the following is correct in respect of the question and the statements? Here we need to answer the question. How far is city P from city Q? For this, 2 statements are given. Now see the first statement. S1. City Q is 18 km from city R. City Q, distance between city Q and R is 18 km. So from statement 1, we can't find what is the distance between city P and Q. Therefore, statement alone is sufficient to answer the question. We can eliminate this option. Now see the second statement. City P is 43 km from city R. City P is 43 km from city R. 43 km. So from the second statement alone, we cannot find the distance between city P and city Q. Therefore, statement 2 alone is sufficient to answer the question. This also we can eliminate. Now, just to combine these two statements, Q, R, P. QP it is 18 km and PR it is 43 kilometers. Then PQ. Now, how far is city P from city Q? PQ, if they are in straight line, then we just have to add 18 plus 43. But that is not said anywhere. So, we cannot say this is the distance between P and Q. P may be here also, or anywhere around R. So all these are distance between P and Q. So even using both these statements, we cannot say what is the distance between P and Q. Therefore, both statement 1 and statement 2 are not sufficient to answer the question. Option D is the right answer. Question number 38. Two statements followed by 4 conclusions are given below. Statement 1. All pens are books. Statement 2. No chair is pen. Conclusion 1. All chairs are books. Conclusion 2. Some chairs are pen. Conclusion 3. All books are chairs. Conclusion 4. No chair is a book. Which one of the following is correct? Here we have 2 statements and 4 conclusions. Based on these 2 statements, we need to check which all conclusions are correct. So statement 1. This we can solve by drawing Venn diagrams. Statement 1. All pens are books. Suppose this circle indicating all pens and this blue circle indicating all books. Then all pens are books. Second statement. No chair is a pen. No chair is a pen. So there is no relation between this red circle and the circle which we are drawing here for chair. No chair is a pen. This we can draw in this way too. Here it is pen. Then this is book. Then no pen is chair, in this way. Now see the first conclusion. All chairs are books. All chairs are not book. All chairs are book, only a possibility. Therefore, conclusion 1 is incorrect. Conclusion 2. Some chairs are pen. No chair is a pen. Therefore, some chairs are pen is not correct. Conclusion 3. All books are chairs. All books are chairs. This is not possible because all pens are books and no pen is a chair. Therefore, all books are chair is definitely not possible. This is also incorrect. Conclusion 4. No chair is a book. No chair is a book. From the first figure, no chair is a book. In the second figure, some chair is a book. So, no chair is a book, only a possibility. Therefore, conclusion 4 also not correct. So, we can say none of the conclusions follows the given statement, given 2 statements here. Option D is the right answer. Question number 39. 3 statements followed by 3 conclusions are given below. Statement 1. Some doctors are teachers. Statement 2. All teachers are engineers. Statement 3. All engineers are scientists. Conclusion 1. Some scientists are doctors. Conclusion 2. All engineers are doctors. Conclusion 3. Some engineers are doctors. Which one of the following is correct? Here 3 statements are given. Based on this, 3 conclusions also given. We need to find which of the following conclusions are correct based on the given statement. This is a problem from syllogism. Syllogism problems we can solve by drawing Venn diagrams. See the first statement. Some doctors are teachers. Suppose this is all in this circle are doctors, and all in this blue circle are teachers. Then some doctors are teachers here, common area. Then second statement, all teachers are engineers. All teachers are engineers. Then third statement, all engineers are scientists. All engineers are scientists. Now see the first conclusion. Some scientists are doctors. Some doctors are teachers, and all teachers are scientists. Then we have a common area here. Some scientists are doctors. Conclusion 1 is correct. Now see the conclusion 2. All engineers are doctors. From the figure, all engineers are not doctors. So all engineers are doctors is only a possibility. This is not correct. Conclusion 3. Some engineers are doctors. Here we can see some doctors are teachers. Then all teachers are engineers. Then we have a common area for engineers and doctors. That means this is this one. That means some engineers are doctors. Conclusion 3 is correct. Then from the given options, we can say both conclusion 1 and conclusion 3 are correct. Option C is the right answer. Question number 40. 8 students A, B, C, D, E, F, G and H sit around a circular table, equidistant from each other, facing the center of the table, not necessarily in the same order. B and D sit neither adjacent to C nor opposite to C. A sits in between E and D. F sits in between B and H. Which one of the following is definitely correct? There are 8 students A, B, C, D, E, F, G and H. They are sitting around a circular table, equidistant from each other, facing the center of the table. Suppose this is the table. Then they are sitting equidistant from each other. Now B and D sit neither adjacent to C nor opposite to C. Suppose C is sitting here. Then these are the adjacent seats of C. B and D not sitting here, and they are not sitting opposite to C also. Then A sits in between E and D. A sits in between E and D. F sits in between B and H. Then which one of the following is definitely correct? So which one of the following is always correct? That is what we have to find. Let us draw the table again. Suppose C is sitting here. Then E, A, D are sitting together. I am placing E here, A here, D here. And B, F, H, they are sitting together. H here, F here, B here. F is sitting in between H and B. Then the remaining G sitting opposite to C. I can draw a different arrangement based on the given statements here. C is sitting here, then E is sitting opposite to C, then A is sitting in between D and E, it is given, then F is sitting in between H and B, then the remaining G sitting adjacent to C. Now see the statements here. B sits in between A and G. B sits in between A and G. In both these figures, B is not sitting in between A and G. Therefore, first statement is not correct. C sits opposite to G. In first statement, it is C is sitting opposite to G, but in the second statement, C is sitting opposite to E. Therefore, C sits opposite to G is not definitely correct. Second one also incorrect. E sits opposite to F. E sits opposite to B in this figure. E sits opposite to F in this figure, in the second figure. So we can say it is not always correct. So this is also incorrect. So the answer is option D. None of the above is definitely correct based on the given informations here. Question number 45. 5 friends P, Q, X, Y and Z purchased some notebooks. The relevant information is given below. First one, Z purchased 8 notebooks more than X did. Second one, P and Q together purchased 21 notebooks. Third one, Q purchased 5 notebooks less than P did. Fourth one, X and Y together purchased 28 notebooks. Fifth one, P purchased 5 notebooks more than X did. If each notebook is priced 40, then what is the total cost of all notebooks? So here 5 friends purchased notebooks. Each notebook cost 40 rupees. Then we want to find total cost of all the notebooks. For this some informations are given here. So from the first statement, Z purchased 8 notebooks more than X did. Z purchased 8 more notebooks than what X did. So this is equation 1. From second statement, P and Q together purchased 21 notebooks. P plus Q equal to 21. This is second equation. Q purchased 5 notebooks less than P did. Q purchased 5 notebook less than P did. This is third one. X and Y together purchased 28 notebooks. X plus Y equal to 28. This is fourth one. P purchased 5 notebooks more than X did. P purchased 5 notebooks more than X did. So this is fifth one. Then from second and third equation, you can write P plus Q equal to 21. From third equation we can write P minus Q equal to 5. I took this q right side and 5 left side, then it becomes p minus q equal to 5. This is from 2 and 3. Then adding these two, we get 2p equal to 26, p equal to 13. When p equal to 13, then from equation number 5, we can write x equal to 13 minus 5, which is equal to 8. When x equal to 8, then from here y equal to 20. 28 minus 8, we get 20. Where p equal to 13, that means from equation 3, q equal to 8. 13 minus 5, we get q, which is equal to 8. Then from equation 1, x equal to 8, then z equal to 8 plus 8 equal to 16. Now we got all the values. Now we can find the total cost of all the notebooks. Total cost of all the notebooks equal to total number of notebooks equal to p plus q plus x plus y plus z. Then each notebook cost 40. Here p equal to 13, q equal to 8, x equal to 8, y equal to, here y equal to 20 and z equal to 16 into 40. Adding these, we get 32, then 52, 55, 65. 65 into 40, we get rupees 2,600. So total cost of all the notebooks equal to rupees 2,600. Option A is the right answer. Question number 46. A man started from home at 14:30 hours and drove to village. Arriving there when the village clock indicated 15:15 hours. After staying for 25 minutes, he drove back by a different route of length 1.25 times the first route, at a rate twice as fast, reaching home at 16 hours. As compared to the clock at home, the village clock is. A man started from home at 14:30 hours. 14:30 hours. He reached the village when the village clock indicated 15:15 hours. He stayed there for 25 minutes. Then he left to home. So 15:15 plus 25 equal to, he drove back to home at 15:40 hours. And he reached home at 16 hours. Then it said he drove back by a different route of length 1.25 times the first route. Suppose first route distance equal to d. Then the second route is 1.25 d. Then it is said a rate twice as fast, reaching home. He drove double the speed while going back to home. So initially the speed was s. While going back to home, his speed was 2s. Then there is some difference in village clock. That is what we have to find. Let us take an x minute difference in village clock. difference in village clock equal to? This is equal to x minute. X minutes. That means if it may be either ways, either it is moving slow or moving fast. If the village clock is moving fast, then we deduct x from this 1515. If it is slow, then we have to add x to this 1515. So there is a change of x minutes. Then time taken by man to reach village equal to 45 minutes plus x minutes. Then he left the village at 40 hours and plus x minutes. Then time taken by him to reach home equal to 16 minus 15 40 hours plus x minutes. This is equal to 20 minus x minutes. Now we got both the times, the time taken by him to reach village and time taken by him to reach back home. So then we know speed equal to distance divided by time. From here time equal to speed, time equal to distance divided by speed. Distance divided by speed. Then we can say here time equal to 45 plus x equal to d by s. Here 20 minus x equal to 1.25 d by 2s. From here 20 minus x into 2 divided by 1.25 equal to d by s. Then equating these two equations, we get 45 plus x equal to 20 minus x into 2 divided by 1.25. Solving this equation, we get x equal to minus 5 minutes. That means here village clock is 5 minutes fast. We have to deduct that 5 minutes from the time 15:15. Then only we get the actual time. So we can say the village clock is 5 minutes fast as compared to the clock at home. Option D is the right answer. Question number 47. A person X wants to distribute some pens among 6 children. A, B, C, D, E and F. Suppose A gets twice the number of pens received by B, 3 times that of C, 4 times that of D, 5 times that of E and 6 times that of F. What is the minimum number of pens X should buy so that the number of pens each one gets is an even number? A person X wants to distribute some pens among 6 children A, B, C, D, E and F. Suppose number of pens get to A equal to A. Then A gets twice the number of pens that received by B. This A equal to twice the number of pens received by B. Then 3 times that of C. A equal to 3 times that of C, 4 times that of D, then 5 times that of E and 6 times that of F. A equal to 5 times that of E and A equal to 6 times that of F. Then what is the minimum number of pens X should buy so that number of pens each one gets is an even number? This is very important. Each one should get even number of pen. From A equal to B, we can say B equal to A by 2. Similarly, from here C equal to A by 3. From here D equal to A by 4. From here E equal to A by 5. And from here F equal to A by 6. Then total number of pen. Total number of pens distributed by X equal to, let us take it as T. This is equal to A plus B plus C plus D plus E plus F. Then T equal to A plus B equal to A by 2. A plus A by 2 plus C equal to A by 3 plus D equal to A by 4 plus E equal to A by 5 plus F equal to A by 6. Then adding these, take A outside, then 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6. Take the LCM, so we get 60. Then 60 plus 30 plus 20 plus 15 plus 12 plus 10. Adding all these, we get A into 147 divided by 60. This is what total number of pens distributed. From here we get T equal to 60. From here A equal to 60 into T divided by 147. So here A should be an integer. We cannot have a 1.5 pen. So A should be an integer. For that, what would be the value of total number of pens? From options, option A and option C, it is 147 and 294. When total number of pens T equal to 147, then A equal to 60 into 147 divided by 147. We get 147 cancelled. We got A equal to 60. Then when T equal to 294, option C 294, then A equal to 60 into 294 divided by 147. Two 147s are 294. Then we get A equal to 60. A equal to 120. 60 into 2 equal to 120. So from the given options, A can take either 60 or 120. We want to find the minimum value of T, and one more condition is everyone should get even number of pens. So let us see which one value of A, 60 or 120, gives even number of pens to all the children. So 60 when total equal to 147, 120 when T equal to 294. Then B equal to A by 2, 30. Here C equal to A by 3, 20. D equal to 60 by 4, 15. So 15 is an odd number. So we can rule out T equal to 147. This is not the answer. Option C is the right answer. Now let us see the values of other members when A equal to 120. B equal to 120 by 2 equal to 60. C equal to 120 by 3, 40. D equal to 120 divided by 4 is equal to 30. E equal to 120 divided by 5 equal to 24. And F equal to 120 divided by 6 equal to 20. All these are even numbers. So option C is the right answer. Total number of pens equal to 294. Question number 48. 6 persons A, B, C, D, E and F are sitting equidistant from each other around a circular table. They are facing the center of the table. Consider the question and 2 statements given below. Question: who is sitting on the immediate left of A? Statement 1. B is sitting opposite to C and D is sitting opposite to E. Statement 2. F is sitting on the immediate left of B. Which one of the following is correct in respect of the question and the statements? There are 6 persons A, B, C, D, E and F. They are sitting equidistant from each other around a circular table. And they are facing the center of the table. Then we need to answer the question, who is sitting on the immediate left of A, for which we have 2 statements here. See the first statement. Statement 1. B is sitting opposite to C. B is sitting opposite to C and D is sitting opposite to E. D is sitting opposite to E. Then the remaining 2 A and F are sitting opposite to each other. So from the first statement we can only say F is sitting opposite to A, and we cannot answer who is sitting on the immediate left of A. So we can eliminate the first option. Statement 1 alone is sufficient to answer the question. Now see the statement 2. F is sitting on the immediate left of B. F is sitting on the immediate left of B. So F is sitting here and he is facing the center. Then this is the left side of B and this is the right side of B. Then F is sitting on the immediate left of B. Immediate left of B is here. So this is the position of F. So from the second statement we can only say the positions of B and F with respect to them. So statement 2 alone is not sufficient to answer the question, who is sitting on the immediate left of A. So statement option B also eliminated. Now let us combine both the statements. Then from first statement, C is sitting opposite to B. C is sitting opposite to B. C is sitting here. And A is sitting opposite to F. Then A is facing the center of the table. Then this is right side of A and this is left side of A. C is sitting on the right side of A. And on the left side of A, it can be either, if it is D here, then opposite to D it is E, or if E is sitting here, then opposite to E, here it is D. So on the left side of A, it can be either D or E. So we cannot definitely say who is sitting on the immediate left of A. So both statement 1 and statement 2 are not sufficient to answer the question. We can eliminate option C also. Then the answer is option D. Both statement 1 and statement 2 are not sufficient to answer the question. Who is sitting on the immediate left of A? Question number 49. Consider the question and two statements given below. Question. What is the age of Manisha? Statement 1. Manisha is 24 years younger than her mother. Statement 2. 5 years later, the ages of Manisha and her mother will be in the ratio 3:5. Which one of the following is correct in respect of the question and the statement? Here we need to answer the question, what is the age of Manisha? For which two statements are given. We need to check whether these statements are enough to answer this question. Let us see the first statement, statement 1. Manisha is 24 years younger than her mother. Let us take present age of Manisha is equal to MA and present age of her mother equal to MO. Then Manisha is 24 years younger than her mother. That means age of Manisha equal to age of mother minus 24. This is equation 1. So based on statement 1, we have one equation. In this equation, there are two variables and only one equation. Therefore, based on this statement alone, we cannot answer the question, what is the age of Manisha? So we can eliminate first option. Statement 1 alone is not sufficient to answer this question. Then, see the second statement, S2. 5 years later, the ages of Manisha and her mother will be in the ratio 3:5. 5 years later, Manisha's age will be present age MA plus 5 and her mother's age will be present age MO plus 5 and their ratio equal to 3:5. Here we get another equation. So based on the second statement, we got another equation. There also there are two variables and one equation. So we cannot find the value of MA. So we cannot answer the question, what is the age of Manisha, with the statement 2 alone. So we can eliminate option B also. Now consider both the statements, S1 and S2. Then two equations and two unknowns. Two equations and two unknowns. So we have a definite value for MA. So by solving these two equations, we can find MA. So both the statements 1 and statement 2 are sufficient to answer the question. Option C is the right answer. If you want to find the value of MA, then solve both the equations. So from first equation, MA equal to MO minus 24. MA equal to MO minus 24. From here, MO, mother's age equal to, present age equal to Manisha's present age plus 24. Put value of MO in second equation. Then MA plus 5 divided by, instead of MO, MA plus 24 plus 5. This is equal to 3:5. Then solving this equation. Here only one variable and one equation. We will get the value of MA. Solving this, we get 5 MA plus 25 equal to 3 MA plus 3 into 29, we get 87. Then 5 MA minus 2 MA, we get 3 MA, we get 2 MA equal to 87 minus 25, we get 62. Then value of MA equal to 62 divided by 2, we get 31. present age of Manisha equal to 31. We could answer the question, what is the age of Manisha, using both the statement 1 and statement 2. Option C is the right answer. Question number 50. 6 lectures A, B, C, D, E and F, each of 1 hour duration, are scheduled between 8 am and 2 pm. Consider the question and 2 statements given below. Question: which lecture is in the third period? Statement 1. Lecture F is preceded by A and followed by C. Statement 2. There is no lecture after B. Which one of the following is correct in respect of the question and the statements? There are 6 lectures A, B, C, D, E, F, each of 1 hour duration, are scheduled between these 6 hours. Now we need to answer which lecture is in the third period, for which 2 statements are given. We need to check whether these 2 statements are enough to answer this question. So let us see the first statement. Lecture F is preceded by A and followed by C. Lecture F is preceded by A and followed by C. So based on the first statement, we can only say these A, F, C lectures are together, and these can be placed anywhere in this 6 period lectures, 6 period duration. So if I am keeping A, F, C here, then in the third period it is C. Suppose I am keeping A, F, C in this way, then third period it is F. So like that, if I am keeping A, F, C in this way, then third period is A. So based on the first statement alone, we cannot answer the question which lecture is in the third period. Therefore, we can eliminate the first option. Statement 1 alone is sufficient to answer the question. Now see the second statement. There is no lecture after B. That means the last lecture in this 6 hour period, it is B. So we are keeping last lecture as B. Then which is the third lecture based on the second statement? It can be any of the remaining 5 lectures. So based on the statement 2 alone, we cannot answer the question. Therefore, we can eliminate the second option also. Now, based on both the statements, based on second statement, the last lecture is B. Then based on the first statement, you can keep A, F, C anywhere on this 5 period. So we already seen it can be either C on the third period, or F on the third period, or A on the third period. So even after combining these 2 statements, we could not answer which lecture is in the third period precisely. Therefore, we can say both statement 1 and statement 2 are not sufficient to answer the question which lecture is in the third period. Question number 54. Let A, B and C represent distinct non-zero digits. Suppose X is the sum of all possible 3-digit numbers formed by A, B and C without repetition. Consider the following statements. Statement 1. The 4-digit least value of X is 1332. Statement 2. The 3-digit greatest value of X is 888. Which of the above statements is or are correct? So there is a 3-digit number which is formed by A, B, C, where A, B and C are distinct non-zero digits. So non-zero digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you can choose 3 numbers from this and form 3-digit numbers. Suppose I am choosing 3, 4, 5. Then I can form 3, 5, 4. Then 4, 5, 4, 5, 3. Like this, I can make different numbers using these 3 digits. So x is the sum of all these numbers. Then they are asking the 4-digit least value of x is. So before finding the 4-digit least value, first find the least value of x. When we get the least value of x, when we choose least digits from this, least digits are 1, 2, 3. So using these 3 digits, how many 3-digit numbers are possible? 1, 2, 3. 1, 3, 2. Total 6 numbers are possible because total number of arrangement possible for with these 3 digits are 3 factorial. 3 factorial equal to 6. So let us write down all those 6 arrangements. Then summing this we get value of x. 1, 3, 2. Then 2, 1, 3. 2, 3, 1. Then 3, 2, 1. 3, 1, 2. So these are the 6 numbers possible by these 3 digits. Then adding all these numbers, 2 plus 1, 3, 3 plus 1, 4, 4 plus 7, 4 plus 3 equal to 7, then 7 plus 2, 9, 9 plus 3 equal to 12, then carry over 1, again here also we get 12 plus 1, 3, here it is 13. So the least possible value of x equal to 1332, and that is also the 4-digit least value of x. So statement 1 is true. Now the 3-digit greatest value of x is, the least value itself, it is a 4-digit number. So the 3-digit greatest value of x is 888 is wrong. Only statement 1 is true. Option A is the right answer. Question number 55. There is a numeric lock which has a 3-digit pin. The pin contains digits 1 to 7. There is no repetition of digits. The digits in the pin from left to right are in decreasing order. Any 2 digits in the pin differ by at least 2. How many maximum attempts does one need to find out the pin with certainty? So there is a lock, it has a 3-digit pin, its digits are taken from digits 1 to 7, no repetition of digits, the digits in the pin from left to right are in decreasing order, and any 2 digits in the pin differ by at least 2. That means if first digit is 7, then there should be at least a 2 difference with the second digits. So second digit is 5 and third digit should be, there should be at least 2 difference with the third digits. So third digit is 3. And from left to right, it is in the decreasing order. It is given here. 7, 5, 3. And at least 2 means we can have another pin 7, 4, 2. Here the difference is 3. So there should be at least 2 difference. Then how many maximum attempts does one need to find out the pin with certainty. So if you are trying for this many attempts, you can definitely unlock the lock. So how many attempts required? That is what we have to find. So first digit, second, third. If first digit is 7, then possible second digits are 5, 4, 3. If second digit is 5, then possible third digits are 3, 2, 1. Here 2, 1. Here 1. 7, 3, 1 is one of the pin. 7, 5, 3. 7, 5, 2. 7, 5, 1. Total 3. 7, 4, 2. 7, 4, 1. Total 2. 7, 3, 1. Here 1. Then first digit is 6. Then possible second digits are 4, 3. Then third digits are, if second digit is 4, then third digits are 2, 1. Here it is 1. 6, 4, 2 is a pin. 6, 4, 1 is a pin. So 2. 6, 3, 1 is a pin. So here only 1. Then first digit is 5. Second digit is 3. Third digit is 1. So 5, 3, 1 is a pin. Total 3 plus 2, 5, 6, 7, 8, 9, 10. Total 10 pins are possible with this condition. So maximum 10 attempts one required to find out the pin with certainty. Option C is the right answer. Question number 56. There are 8 equidistant points on a circle. How many right-angled triangles can be drawn using these points as vertices and taking the diameter as one side of the triangle? So a circle is marked by 8 equidistant points. 1, 2, 3, 4, 5, 6, 7, 8. Then how many right-angled triangles can be drawn using these points as vertices? And we have to take one of the side of the triangle as diameter of this circle. So any two points joining, any two opposite points joining, we get a diameter. So this is first diameter, this is 1. Then 6 and 2, we get the second diameter. Then 1 and 5, we get the third diameter. 8 and 4, we get the fourth diameter. So 4 such diameters are possible. Now let us see how many right-angled triangles can be drawn. 1, 2, 3, 4, 5, 6, 7, 8. I am joining 7 and 3. It is a diameter. Then any triangle with third vertex as a point on the circle, we get a right-angled triangle. So this is a right-angled triangle. If I am joining 7, 2, 3, this is a right-angled triangle. 7, 1, 3 is another right-angled triangle. So any triangle which is made up of diameter and a point on the circle as a vertex, then it is a right-angled triangle. So all these are right angle triangle. So from one diameter, using other points of the third vertex, we got 6 right angled triangles. So there are 4 diameters. Then from 4 diameters, from each diameter we get 6 triangles. Then 4 into 6, there are 24 right angled triangles. Option A is the right answer. Question number 57. 24 men and 12 women can do a piece of work in 30 days. In how many days can 12 men and 24 women do the same piece of work? Here, 24 men and 12 women can do a piece of work in 30 days. 24 men and 12 women can complete a piece of work in 30 days. Then, how many days it will take by 12 men and 24 women to finish the same work? 12 men and 24 women. How many days to finish the same work? Here, the efficiencies of men and women are not given. Suppose men is equally efficient as that of women, then number of workers is same in both the case. Therefore, 12 men and 24 women can finish the work in 30 days. If men is more efficient than women, then more efficient men is replaced by less efficient women. That means they will take more than 30 days to finish the work. If men is less efficient than women, then less efficient men is replaced by more efficient 12 women. That means they can finish the work in less than 30 days. So all these possibilities are there. So we cannot make any conclusion to find one answer. So data is inadequate to draw any conclusion. Option D is the right answer. Question number 58. What is the remainder when 91 into 92 into 93 into 94 into 95 into 96 into 97 into 98 into 99 is divided by 1261. So here we want to find the remainder when this product divided by 1261. So let us find it. 91 into 92 into 93 into 94 into 95 into 96 into 97 into 98 into 99 all divided by 1261. This 1261 we can write as 1261 equal to 13 into 97. These two are the only factors of 1261 other than 1 and itself. And these two are prime numbers as well. Then instead of 1261, let us write 13 into 97. This 97 cancelled. 91 equal to 7 into 13. Then this 13 also cancelled. That means this product is exactly divisible by 1261. The remainder is 0. Option D is the right answer. Question number 59. Consider the following statements in respect of a rectangular sheet of length 20 cm and breadth 8 cm. Statement 1. It is possible to cut the sheet exactly into 4 square sheets. Statement 2. It is possible to cut the sheet into 10 triangular sheets of equal area. Then, which of the above statements is or are correct? Here we have a rectangular sheet of length 20 cm and breadth 8 cm. Its length equal to 20 cm and breadth equal to 8 cm. Then first statement, it is possible to cut the sheet exactly into 4 square sheets. Exactly means we have to use this sheet completely and we have to make 4 square sheets. Suppose I am cutting this sheet into 2 8 by 8, 2 8 by 8 squares. So we got 2 squares. Then the remaining sheet is, this is the remaining length is 4 cm. So we get a small piece of sheet 4 cm and 8 cm. Then we can cut this into 2 square sheets of 4 cm. Here we got 2 more square sheets. So the statement is, it is possible to cut the sheet exactly into 4 square sheets and we could cut 4 square sheets from this 20 by 8 rectangular sheet. So the statement 1 is true. Now see the statement 2. It is possible to cut the sheet into 10 triangular sheets of equal area. This is the rectangular sheet 20 cm and 8 cm. First cut this into 5 equal sheets. Then each sheet we can cut into 2 triangular sheets and all of them have same area. So the statement 2 also correct. Our answer is both statement 1 and statement 2 are correct. Option C is the right answer. Question number 60. When 70% of a number x is added to another number y, the sum becomes 165% of the value of y. When 60% of the number x is added to another number z, then the sum becomes 165% of the value of z. Which one of the following is correct? Here, 3 numbers are there, x, y and z. Then 70% of number x is added to another number y. 70% of x means this we can write in the form of fraction 70 divided by 100. 70% equal to 70 divided by 100 into x. This is equal to 0.7x. So 0.7x is added to another number y. The sum equal to 165% of the value of y. So 165% equal to 1.65 y. This is equation 1. Now see the second statement. When 60% of the number x is added to another number z, 60% of x is added to another number z, the sum equal to 1.65 z. This is equation 2. Then which of the following is correct? So from 1, 0.7x equal to 0.65 y. So From here it is clear that y is greater than x, or this implies x equal to 0.65 divided by 0.7y. Denominator is greater than numerator. That means x is only a fraction of y. Therefore, y is greater than x. Now, see the second equation. 0.6x equal to 0.65 z. I took this z right side, then it becomes 0.65 z. From here, it is clear that 0.6x equal to 0.65 z. That means x is greater than z, or z equal to 0.6 divided by 0.65 x. So z is only a fraction of x. That means x is greater than z. So combining these two, we get x is greater than z and y is greater than x. So y greater than x greater than z, or z less than x less than y. Z less than x less than y. Option A is the right answer. Question number 64. Two candidates X and Y contested an election. 80% of voters cast their vote and there were no invalid votes. There was no no option. X got 56% of the votes cast and won by 1440 votes. What is the total number of voters in the voters list? There are two candidates in this election, X and Y. 80% of the voters cast their vote. No invalid votes, no nota option. That means each vote goes to either account of X or to the account of Y. X got 56% of the votes and won by 1440 votes. What is the total number of voters in the voters list? Total number of voters. Let us take total number of voters equal to T. Then 80% of the total number of voters cast their vote. So total polled votes equal to 80% of T. This is equal to 0.8 T. Then X got 56% of total polled votes, that is 0.8 T. Then the remaining 44% of 0.8 T won by Y. Then here it is said that X won by 1440 votes. That means majority. X got 1440 votes more than that of Y. That is called majority. So 56% of 0.8 T minus 44% of 0.8 T, we get 12% of 0.8 T. This is equal to 1440. So 12% means 12 divided by 100 into 0.8 T equal to 1440. From here we get T equal to 15,000. Total number of voters in the voters list equal to 15,000. Option A is the right answer. Question number 65. What is the smallest number greater than 1000 that when divided by any one of the numbers 6, 9, 12, 15, 18 leaves a remainder of 3? Here we want to find smallest number greater than 1000 which gives a remainder 3 while dividing with any one of these numbers. This question we can do easily by eliminating options. Deducting 3 from these options, we get a number which is divisible by all these numbers. So let us see the first option, 1063. When deducting 3, we should get a number which is divisible by all these numbers. If it is not divisible, then we can eliminate this option. So what is the divisibility test for 9? Sum of digits is divisible by 9. Sum of 1060 equal to 7. 7 is not divisible by 9. Therefore, this is not the answer. We can eliminate this option. Because 1060 is not the smallest number greater than 1000 which is divisible by all these numbers. Now see the next number, option B, 1073. So after deducting 3 we get 1070. Sum of these number digits equal to 8. 8 is not divisible by 9. Therefore, we can eliminate option B also. Then option C, 1083. 1080. Sum of digits equal to 9, which is divisible by 9. Therefore, this can be our answer. Now see the option D also, 1183. Then 1180. Sum of its digits equal to 10. 10 is not divisible by 9. Therefore, we can eliminate this option also. So, the right answer is option C. So, you can check with any one of these numbers, divisibility test of any one of these numbers. Now, I just considered 9 and from there itself we got answer as option C, 1083. Otherwise, we can solve this question by finding common multiple, smallest common multiple greater than 1000. What is the least common multiple of these numbers? Least common multiple of these numbers equal to 396 59. We can find least common multiple by prime factorization. Then by 3, 1, 3, 1, 5, 3. Then by 3 again, 1, 1, 1, 5, 1. And finally 5, 1, 1, 1, 1, 1. Then LCM equal to 2 into 2 into 3 into 3 into 5, we get 180. This is the least common multiple, but we want to find common multiple greater than 1000. So 6 into 180, we get 1080. So this 1080 is exactly divisible by all these numbers. Then we want to find a number which give remainder 3. So adding remainder 3 to this number to get remainder 3. Add 3 to this number. Now this is a number which is the smallest number greater than 1000. When divided by any one of these numbers leaves a remainder of 3. So option C is the right answer. Question number 66. Let P be a 2-digit number and Q be the number consisting of same digits written in reverse order. If P into Q equal to 2430, then what is the difference between P and Q? P and Q are two 2-digit numbers where one number is formed by reversing the digits of other number. That means if suppose P is formed by digits A and B, then Q equal to B A. Then they said P into Q equal to 2430. Then what is the difference between P and Q? Here we need to find the difference between P and Q. For that we need the values of P and Q. P into Q equal to 2430 means P and Q are the factors of 2430. That means 2430 is exactly divisible by both P and Q. Then P into Q we are getting units place digits equal to 0. To get units place digit equal to 0, either B or A should be 5. Suppose B equal to 5, then A should be a even number. Then multiplying AB, we get last digit equal to 0. A into B, even number into 5, we get the last units place digit equal to 0. Now that means one of the factor has units place equal to 5. Now let us find the 2-digit factors of 2430. Factorizing 2430, we get 2. By 2 we get 1, 2, 1, 5. Then by 3 we get 4, 0, 5. Again by 3 we get 1, 3, 5. Again by 3 we get 45. 45 is one of the factor of 2430 and 5 is the last digit or units place digit. Then multiplying these numbers 2 into 3 into 3 into 3 into 45, we get 2430. So 45 is one of the factor. Then 2 into 3 into 3 into 3, this is equal to 54. This is another factor. Revising the digits of 45, we are getting 54. Therefore these are the two numbers we are looking for. P equal to 54 and Q equal to 45. Difference between P and Q equal to P minus Q equal to 54 minus 45, we get 9. Therefore the required answer for the question, the difference between P and Q equal to 9. Option D is the answer. Question number 67. Consider the following statements in respect of two natural numbers p and q such that p is a prime number and q is a composite number. Statement 1. P into q can be an odd number. Statement 2. Q by p can be a prime number. Statement 3. P plus q can be a prime number. Then, which of the following above statements are correct? Here, there are two natural numbers p and q, where p is a prime number and q is a composite number. Then, which of the above statements are correct? There are two natural numbers prime, one is prime and other is composite. P is a prime number and q is a composite number. Prime numbers means it has only two factors, one and itself. 3, 2, 3, 5, 7, 11, 13, all these are prime numbers. Then composite numbers means it has factors other than 1 and itself. 4, 6, 9, 10, then 12, all these are composite numbers. Then let us see, p into q can be an odd number. Suppose p equal to 3, it is a prime number. Q equal to 9, it is a composite number. Then p into q equal to 3 into 9 equal to 27. It is a odd number. So p into q can be an odd number, which is correct. Now see the second statement. Q by p can be a prime number. Q, it is a composite number, 6. P is a prime number, 2. Then q by p, 6 by 2 equal to 3, which is a prime number. So q by p can be a prime number. This is also correct. Now see the third statement. P plus q can be a prime number. P equal to 2, p equal to 2 and q equal to 3. Then p plus q equal to 2 plus 3 equal to 5. It is a prime number. So p plus q can be prime number. This is also true. Then all the three statements are correct. Option D is the right answer. Question number 68. Consider the following statements. Statement 1. Between 3:16 p.m. and 3:17 p.m. both hour hand and minute hand coincide. Statement 2. Between 4:58 p.m. and 4:59 p.m. both minute hand and second hand coincide. Which of the above statements is or are correct? Consider the statement 1. Between 3:16 p.m. and 3:17 p.m. both hour hand and minute hand coincide. When both hour hand and minute hand coincide, the angle between them equal to 0. We know to find the angle between hour hand and minute hand, the equation is theta equal to 11 divided by 2 into x minus h into 30, where theta is the angle between hour hand and minute hand. 11 by 2 means relative angular movement of minute hand and hour hand for each minute. That is, for 1 minute, relative angular movement of minute hand and hour hand equal to 11 by 2 degree. Then x means minutes passed, h means hours passed. Here we want to find when both hour hand and minute hand coincide after 3 o'clock. Therefore, H equal to 3. Then 30 means for each hour, our hand move by 30 degree. Then when both hands coincide, theta equal to 0. Then 11 by 2 into, here we want to find minutes passed. Then H equal to 3 into 30. Rearranging this, we get 11 by 2 x equal to 90 degree. X equal to 180 divided by 11. This is equal to 16.36 minutes. This is equal to between 3:16 p.m. and 3:17 p.m. both hour hand and minute hand coincide. Statement 1 is correct. Now see the statement 2. Between 4:58 p.m. and 4:59 p.m. both minute hand and second hand coincide. For each minute movement of minute hand, second hand complete one rotation. For each minute movement of minute hand, second hand complete one rotation. Therefore, they will definitely coincide each other. Statement 2 also correct. Therefore, the answer is both 1 and 2 are correct. Question number 69. There are two containers X and Y. X contains 100 ml of milk and Y contains 100 ml of water. 20 ml of milk from X is transferred to Y. After mixing well, 20 ml of the mixture in Y is transferred back to X. If M denotes the proportion of milk in X and N denotes the proportion of water in Y, then which one of the following is correct? There are two containers X and Y. X contains 100 ml of milk, Y contains 100 ml of water. X contains 100 ml of milk, Y contains 100 ml of water. 20 ml of milk from X is transferred to Y. Then in container X, 100 minus 20 equal to 80 ml milk is remaining. In container Y, 100 ml of water plus 20 ml of milk gives 120 ml of milk plus water. Then after mixing well, 20 ml of the mixture in Y is transferred back to X. Then from this 120 ml of the mixture, 20 ml is transferred to X. Then in Y, 100 will be remaining. In X, 80 plus 20 ml of water plus milk, we get 100 ml. So after all mixing, we got 100 ml of mixture in X and 100 ml of mixture in Y. Then they said M denotes the proportion of milk in X and N denotes the proportion of water in Y. Then which of the following is correct? M means proportion of milk in X. X contains 100 ml of mixture. N means proportion of water in Y. Y means 100 ml of mixture. Then which of the following is correct? So after all mixing, both the containers having 100 ml of mixture. Suppose A amount of water is moved to container X. Then milk in the container X equal to 100 minus A divided by 100. So that means A amount of water moved from container Y to X. Then water remaining in container Y equal to 100 minus A divided by 100. So here we can see both the values of M and N are equal. Whatever the water moved to container X, the same amount of milk is moved to container Y. Therefore, proportion of milk in container X always equal to proportion of water in container Y. M always equal to N, because both the containers having the same amount of mixture. Option A is the right answer. Question number 70. A pie chart gives the expenditure on 5 different items A, B, C, D and E in a household. If B, C, D and E correspond to 90 degree, 50 degree, 45 degree and 75 degree respectively, then what is the percentage of expenditure on item A? Here, expenditure on 5 different items are represented on a pie chart. So what is meant by pie chart? Representing data in a circle. Here, the included angle around this center of the circle equal to 360 degree. Then it is given that B equal to 90 degree, C equal to 90 degree, C equal to 50 degree, D equal to 45 degree, E equal to 75 degree. Then B equal to 90 degree. This is B. C equal to 50 degree. This is C equal to 50 degree. D equal to 45 degree. E equal to 75 degree. This is E. Then we know total included angle around the circle equal to 360 degree. Then reducing all other angles B, C, D and E, we get the angle of sector A. That is 90 plus 50 plus 45 plus 75. This we get 360 minus 260 equal to 100. Now we want to find what is the percentage of expenditure on A. So we got expenditure on A, percentage of expenditure on A. We got expenditure on A equal to 100 degree and total expenditure equal to 360 degree. Then to get percentage, multiply by 100. This is equal to, here 4 9s are 36, 4 25s are 100, we get 250 divided by 9 percentage. Option D is the right answer. Percentage of expenditure on item A equal to 250 divided by 9. Question number 74. If 15 into 14 into 13 into etc. 3 into 2 into 1 equal to 3 power m multiplied by n, where m and n are positive integers, then what is the maximum value of m? Here 15 multiplied by 14 into 13 into etc. 3 into 2 into 1 equal to 3 power m multiplied by n. We want to find maximum value of m, that is maximum power of 3 in this product of in this multiplication. So we know 15 into 14 into 13 into 12 into etc. up to 1, it is 15 factorial. 15 factorial equal to 3 power m into n. Then to find maximum power of 3 in 15 factorial, just take 15 divided by 3 plus 15 divided by 9. This is equal to 15 divided by 3, we get 5, plus 15 divided by 9, we get 1 point something, but this is greatest integer function, so we get 1. So 5 plus 1 equal to 6. The maximum value of m equal to 6. Our answer is option B. Otherwise we can find 15, we know 3 into 5. So here we have 1 3. Then there will be 12. 12 equal to what? 3 into 4. So we got another 3. Then 9. 9 means 3 square. So we got 2 more 3's. Then in 6, 2 into 3. We got another 3. Then in 3, here only 1 3. So total 1, 2, 3, 4, 3, 4, 5, 6. Total there are 6 3's. So the maximum power of 3 equal to 3 power 6. That is value of m equal to 6. Option B is the right answer. Question number 75. What is the value of x in the sequence 2, 12, 36, 80, 150 x? 2, 12, 36, 80, 150 x. First find the difference between adjacent terms. 12 minus 2, 10. 36 minus 12, 24. 80 minus 36, 44. 150 minus 80, 70. Then x minus 150. We don't know, we have to find the value of x. So let us take this as p. Now we didn't get any clue from here. Again find the difference between adjacent terms. 24 minus 10, which is equal to 14. 44 minus 24, 20. 70 minus 44, 26. Then p minus 70. Here we can see we got another series which is increasing by 6. 14 plus 6 equal to 20. 20 plus 6 equal to 26. Then 26 plus 6 equal to 32. From here we got p equal to 102. 70 plus 32 equal to 102. Then x minus 150 equal to 102. Then x equal to 150 plus 102, 252. Option B is the right answer. Question number 76. One non-zero digit, one vowel and one consonant from English alphabet in capital are to be used in forming passwords. such that each password has to start with a vowel and end with a consonant. How many such passwords can be generated? Here, we want to find how many such passwords are there. It has one non-zero digit, one vowel and one consonant, and also it should be start with a vowel and end with a consonant. So it should start with a vowel and end with a consonant, and in between non-zero digit. So we know in English alphabet A, E, I, O, U are vowels. Total 5 vowels are there. Then remaining 21 are consonants. Total 26 letters are there. Then non-zero digits. There are total 10 digits. We are just removing 0. Then 9 digits are there. Then one of such password is, let us take one vowel from here A, one non-zero digit 1 and one consonant, that is B. A1B is one of such password. How many such passwords are possible? So first place it is vowels. You can choose one vowels out of 5 vowels in 5 ways. You can choose one digits, non-zero digit out of 9 non-zero digits in 9 ways, and you can choose one consonant out of 21 consonant in 21 ways. So multiplying all these, we get total passwords possible. So 5 into 9 into 21 equal to 945. Option C is the right answer. Question number 77. There are 9 cups placed on a table arranged in equal number of rows and columns, out of which 6 cups contain coffee and 3 cups contain tea. In how many ways can they be arranged so that each row should contain at least 1 cup of coffee? There are 9 cups. They are arranged in equal number of rows and columns. 9 cups, 1, 2, 3, 4, 5, 6, 7, 8, 9. Equal number of rows and column means each row contains 3 cups. This is R1, this is R2, this is R3. Then 6 cups contain coffee. Out of 9, 6 cups contain coffee. Then the remaining 3 contain tea. Then in how many ways can they be arranged so that each row should contain at least one cup of coffee? So to have at least 1 cup of coffee, you can arrange this 6 cups of coffee in 3, 2, 1 or 2, 2, 2 ways. Either you can arrange in 3, 2, 1 or you can arrange in 2, 2, 2. In each row, 2 cups of coffee, or in one row 3 cups of coffee, second row 2 cups of coffee, third row only 1 cup of coffee. Now let us see how many arrangements are possible. Case 1. R1 contains 3 cups of coffee. So these 3 cups of coffee, you can keep, all the coffees are similar. So 3 cups of coffee you can just keep in these three places in one way. Then R2, there are 2 cups of coffee. So 2 cups of coffee you can place in 3 places in 3C2 ways. That means choose 2 out of these 3 and keep 2 coffees on those places. So 3C2 equal to 3. Then R1, 1 cup of coffee. This 1 cup of coffee you can keep either in first column or in second column or in third column. So that is equal to choose one place and place it. So that you can do in 3C1 ways, which is equal to 3. This is case 1A. Now case 1B. R1 equal to 3, R2 equal to 1 and R3 equal to 2. Then here also you can have 1 way, 3 ways and 3 ways again. Then from case 1, total number of ways equal to, here it is 1 into 3 into 3. You can arrange this in 9 ways. Here also you can arrange 1 into 3 equal to 9 ways. So from case 1, total arrangements equal to 9 plus 9, 18 ways. Similarly, in case 2, R2 contains 3 cups of coffee. There you can have 18 ways of arrangement. In case 3, R3 has 3 cups of coffee. You can have 18 ways of arrangement. Then total arrangements from 3 to 1 arrangements equal to 3 into 18 equal to 54. Now consider each row contains 2 cups of coffee, R1, R2, R3. Then you can place these 2 cups of coffee in 3 ways, here also 3 ways, here also 3 ways. Then total number of arrangements equal to 3 into 3 we get 27. Then grand total of arrangements equal to 54 plus 27 equal to 81. 81 arrangements are possible. Option D is the right answer. Question number 78. The sum of 3 consecutive integers is equal to their product. How many such possibilities are there? Integer means a number which is not a fraction. Then 1, 1, 2, 3 up to positive infinity. Then 0, minus 1, minus 2, minus 3 up to minus infinity. All these are integers. Here we have to find how many possibilities are there. Well, sum of 3 consecutive integers is equal to their product. Let us take 3 consecutive integers as x minus 1, x and x plus 1. This is 3 consecutive integers. Then their sum equal to x minus 1 plus x plus 1, which is equal to their product, x minus 1 into x plus 1. Then x minus 1 plus x plus 1 equal to 3x, which is equal to x minus 1 into x plus 1 equal to x square minus 1 into x. Then 3x equal to x cube minus x cube minus 4x equal to 0. From here we get x equal to 0 and x square equal to 4. From this we get x equal to 2 or x equal to minus 2. So x can take 3 values, 0, 2 and minus 2. That means there are 3 such possibilities. Option C is the right answer. Now C. We took x minus 1, x and x plus 1 as 3 consecutive integers. When x equal to 0, x minus 1 equal to 0 minus 1 equal to minus 1, 0, then 1. Their sum equal to 0 and their product equal to 0. When x equal to 2, here 1, then 2, then 3. When x equal to minus 2, here it is minus 3, here it is minus 2, minus 2 plus 1 equal to minus 1. So there are 3 such possibilities. The sum of 3 consecutive integers is equal to their product in. There are 3 such set of integers. Option C is the right answer. Question number 79. What is the number of numbers of the form 0.xy, where x and y are distinct non-zero digits? Here we have to find number of numbers which is in the form 0.xy, where x and y are non-zero digits. Non-zero digits are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Total 9 digits are there. 9 non-zero digits are there. So if you are taking 2 digits out of this 9 digits, then suppose you took 4 and 8. Then numbers in the form 0.xy are 0.48 and 0.84. So if you are taking 2 numbers out of this 2 digits out of these 9 digits and arranging them, you will get total number of numbers in the form 0.xy. So you can take 2 digits out of 9 digits in 9p2 ways, and you can arrange those 2 digits in 9p2 ways. So we get 9 factorial divided by 9 minus 2 factorial. 9 factorial equal to 9 into 8 into 7 factorial divided by 9 minus 2 factorial equal to 7 factorial. 7 factorial cancelled. Then 9 into 8 equal to 72. There are 72 such numbers. Option A is the right answer. Question number 80. The average weight of A, B, C is 40 kg. The average weight of B, D, E is 42 kg. And the weight of F is equal to that of B. What is the average weight of A, B, C, D, E and F? here we want to find average weight of these 6 persons. For that, it is given that average weight of A, B, C is 40 kilogram. So we can write this as A plus B plus C divided by 3 equal to 40 kilogram. This implies A plus B plus C equal to, taking these 3 right side, then it becomes 3 into 40, which is equal to 120. This is first equation. Then average weight of B, D, E is 42 kilogram. B plus D plus E divided by 3 equal to 42 kilogram. Then B plus D plus E equal to 126 kilogram. This is second equation. Then it is given that F equal to B. Weight of F equal to that of B. Then we want to find average of A, B, C, D, E and F. Adding equation 1 and 2, we get 1 plus 2. A plus B plus C plus B plus D plus E equal to 120 plus 126. We know B equal to F. Change this B to F. It is given here. Then this equation become A plus B plus C plus D plus E plus F. Dividing this by 6, we get the average of A, B, C, D, E and F. So average of A, B, C, D, E and F equal to 246 divided by 6 equal to 41 kilogram. Option C is the right answer.